Hi, so this is the our practice class about the hypothesis testing, which is chapter 7, sorry. So as I already know, hypothesis about testing if our hypothesis is correct or not, uh, um, given our own data. So we have to select a certain side based on our data. So as I already have done, we actually in previous time did a lot of thing about the estimation, so that from the sample we estimated some parameter in the population based on the sample data. From now on, we are going to do some hypothesis testing. So we are going to make some hypothesis about the population parameter, and then we are going to decide some certain assertion, which in which our population parameter is some value or not based on the sample. So I will assume that you know all of the content. So actually there is a formal process about constructing a hypothesis test. So as the first step, we have to set some null hypothesis and alternative hypothesis. And as I already know, our aim is to go to the alternative hypothesis by rejecting the null hypothesis usually. And then we also have to set the significance level, which is the some probability that we want to some extent that we want to reject the null hypothesis, and also the reject region. And if our test statistic in the reject region, we can reject the null hypothesis, and we are able to go to the alternative hypothesis. And finally, after we construct, or after we get the test statistic based on our knowledge, we can also get the p-value, which is the probability of the of obtaining a test statistic when assuming that the null hypothesis is true. This is the most important thing. So we always assume that our null hypothesis is true, and then we watch the p-value based on the test statistic, because we can get the distribution of the test statistic with with some distribution that we already know, we already have learned. So, and then if p-value is less than or equal to our significance level, or our test, which also means that test statistic is in our own reject region, it means that we can reject the null hypothesis, and we are able to go to the alternative hypothesis. And then it is what hypothesis test is. So this is the whole procedure of the hypothesis testing. So let's go to the example. So I prepared the R code with starting with this example number 1. So they claim, there's their claim, their company claim. So they say that their hyperparameter, I mean the population parameter, which is average, is 4.5. It is their claim. And we want to, let's say that we want to reject the hypothesis, and we want to say that no, the population mu is not equal to 4.5. So this is our null and alternative hypothesis. And we already know that when the null hypothesis is true, when we assume that null hypothesis is true, the x bar follows this distribution, because the problem already said that the weight loss follows normal distribution with sigma is equal to 3. And we observe that the sample mean expires per point 2 with sample size is 10. And let's say that our significance level alpha is equal to the 0.05. And then we can construct our test statistic about the G-score because we know that our G-score, which is standardized value of the normal distribution, follows the standard normal distribution, in which we can calculate some probability from the distribution, standard normal distribution. So this is our assumption, which is population mu, and we observe that our x bar is per point 2. So we want to get some probability when our when the G-score is like this one, like this guy. And then because G-score is this one, we get the p-value by combining the two-sided probability of the normal distribution. So actually this is the same as the multiplication with a probability with 2. So we can get this p-value. So to sum up it, if let's say that assuming that the null hypothesis is true, which says that population mean is per 0.5, we can get the distribution of x bar as well as the distribution of z0, which is our own test statistic. And after we get the p-value, we see that this probability is is much higher than our significance level, which is 0.05, so that we cannot reject the null hypothesis, and we are not able to say that mu the population mu is not equal to per 0.5. We are not able to say that. So this is one of the hypothesis testing about the population mean. And yeah, so I also prepared some code about doing the hypothesis testing. And because I just there is actually no much thing about the programming, because this is all about the theoretical thing, which is hypothesis testing. So the more important thing is that you have to understand what the situation is, and when you have to get the answer. So you have to store the value, which is x bar and sample size here, x bar, which is per 0.2, and sample size is 10 and sigma is 3 here. And we want to say that our population mean is per 0.5, and we assume that our population mean is equal to this value based on this null hypothesis. And then we can get the test statistic by using the values above as we stored, which is same as here. So if you run this code, you can see that our test statistic is about minus 0.316, which is same as this value. And then this is about getting the p-value of the test statistic. And we already know that our test statistic follows the standard normal distribution with 0 mean and standard deviation as 1. And because we are going to do the two-sided test, we multiply the one-sided probability by 2 with value 2, which is here. You can see that the result is 0.75, which is the same as the p-value here. So what I did is just nothing but calculating the test statistic or the p-value here. So there's no much thing about no difficulty in calculating this value if you are already familiar with the theoretical background of the hypothesis testing. And let's go to the example number 2. And our hypothesis testing is about saying about that our population mean mu is 160 or not. And we observed the 15 sample from the experiment. So our sample size is 15, and we know the sample mean by summing up all the values above and then divide it by the sample size. So after I store the vector value here in the example number 2 or the experiment number 2, and we can also get the mean by using the mean function. So it is much easier than just summing up all the value and divide the result by 15. What we can do just here is that we just use the mean function rather than calculating all the thing, which is somewhat burdensome. So it gives us that the mean value is 166.4. So I store the mean value in our own variable x bar. And our hypothesis testing is about mu is equal to 160 or not. So because we assume that the mu is true, the null hypothesis is true, we set the mu as this value. And also the sigma as 10 may be here. And we know that we assume that our sample or our population follows the normal distribution. So sigma is 10 and sample size 15. And then it also says that it also means that we can construct our own test statistic by using this formula. Actually, this is same as the previous one. So there's no much difficulty. And then this is the test statistic. So you can see that test statistic is about minus 0.47. Significance level is 0.05. And then, oops, we are doing this one. So yeah, test statistic is 2.47. Sorry, I was doing the example number 3. And then because our test statistic, we know that our test statistic follows the standard normal deviation, we have to get the p-value by using this formula. So which means that this is the standard normal distribution with 0 mean and sigma is 1, and we want to know the probability when our test statistic, when our standard normal variable is greater than or equal to 2.47, which is same as this probability. Standard normal distribution variable is greater than or equal to 2.47, which is the p-value here in this situation. And it is the same as the 1 minus the probability. Our z variable is less than 2.47. We can now use the, from now on, we can use the formula with the p-norm function and with the lower tail option as true. No. Yeah, true, which is default value. So it says that because the p-value is 0.006, which is less than 0.05, which is significance level, we are able to reject the null hypothesis that our our population mean is 160, and we have enough evidence that we are able to say that, so that we are able to say that our population mean is not equal to 160 from now on, based on our sample, after assume that our null hypothesis is true. So this is the example in which we rejected the null hypothesis and goes to the alternative hypothesis now. So, and there is some question, there has to be some question that, oh sorry, this is not the not equal sign, but you have to make sure that their 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 claim is that their average value is over 160. So if the null hypothesis is this thing, the alternative hypothesis to be the mu is over, which is greater than 160. So this is why we get only the p-value in this side, this right side, not the two side. For example, in the previous example, because our alternative hypothesis about not equal sign, so it is not the greater than or less than sign, it was not equal sign. So that we have to get the two-sided value. I mean minus 0.31 and plus 0.31 here. So to get the p-value, we have to multiply the one-side probability with 2, because this is about two-sided test. Because we set the alternative hypothesis with this not equal sign. However, in this example number 2, it says that our alternative hypothesis is about one-sided test because of this word, over. So that our alternative hypothesis has to be this one, and it is the reason why we get the one-sided probability when we want to get the p-value, and then reject the null hypothesis based on the p-value. So you always have to be careful about the specific word or specific situation that the problem suggests to us. So be careful. And let's go to the example number 3. I will skip this problem, but this is on your own, so do not skip for you. And we already know that even though we don't know the value of the sigma squared, we can also use the sample with the normal distribution, even though we don't know the sigma squared, and then we are just able to use the t distribution rather than instead of standard normal distribution. So what I want to say is that even though we don't know the sigma value, we can use the standard deviation of the sample, and then we can also construct the test statistic based on the standard deviation of the sample with, and it follows the t distribution. So this is the example number 4, and in the code it is named as the example number 3, so don't be confused. And the average is 4.5, they say, is their claim. And our sample size is 10 here. And the X bar sample mean is 4.2. And the problem doesn't give us the sigma squared value, which is the population variance, but it just gives us the sample standard deviation, which is S2. So because we don't know the population variance, we have to use this standard deviation here, and then we already know that the statistic follows the t distribution. So let's start and making sure that the sample or the population follows the normal distribution. So we can construct the test statistic with this formula, which is this one. And we know that our test statistic follow the t distribution. We have to use this probability. And because this is the two-sided test, we have to get the two-sided probability when you want to get the p-value. So we multiply the one-sided value with 2 because the t distribution is symmetric. And this is the same as this one, this formula. After storing the value and getting the test statistic, which is minus 0.47, which is the same as this value. And then after multiply the result of the pt function with 2, we can get the p-value as 0.64, which is the same as this one. So it says that we cannot reject the null hypothesis because the p-value is so larger, much larger than the significance level, which is 0.05. That's it. And let's go to the example number 4. I will skip this problem, but do not skip for you. And we already know that even though we are not sure that our sample comes from the normal distribution, if the sample size is so enough, we can use still the normal distribution because of the large sample approximation. So even though we start any distribution as the population distribution, we always see that, even though we start with any distribution, if the sample size is large enough that we can use the large sample approximation, we know that our sample mean follows the normal distribution like this one. So this is the reason, even though there is no information about the population distribution, if the sample size is so big, we can still use the normal distribution after we construct the test statistic. So this is our hypothesis testing, and we know that our X bar follows this normal distribution because the sample size is so big enough. And then this is the formula for getting the test statistic. And for getting p-value, because we are dealing with a two-sided test, we have to multiply the result of the p-value with 2, which is 0.2531, which is the same as here, 2531 about. That's it. And because this is larger than 0.05, which is significance level, we are still not able to reject the null hypothesis this time. And let's go to the final example. I will also skip this one, but do not skip. And we already know the population proportion distribution. So if we know our p-bar, we know that this formula follows the standard normal distribution. So which means that we can also make the hypothesis testing about this one. And our sample size is 200, and our p bar here is 132 divided by 200, and we want to get the significance level as 0.05, and we want to make a claim that an argument that the cure rate, which is population proportion, is 0.75. We want to make this hypothesis testing about this one here. And because we can use this formula for getting the test statistic in this part, which is same as this one. So the test is about minus 2.93. And then we can also get the p-value by using the p-norm function, because we know that our test statistic follows the normal distribution here with zero mean and standard deviation as 1, which is standard normal distribution. And then multiply it by 2 because we are dealing with a two-sided test here. And then it says that the p-value is about 0.003, which is less than 0.05, which is significance level, which means that we can reject the null hypothesis based on our sample information. So that's it. And there is also a problem, but I will leave it as a DIY, doing yourself. And for the final comment, actually there is some function in R programming, I mean the inner function in R programming, which deals with the population test. So whose name is proportion test, proportion that test. So if you want to see some description about this function, you can run this code and see some detail here. And there in the alternative section, there is two-sided, greater, less. So you can select among these options. And then there is some x value and m value and p value here in this function. So x is 132 and sample size is 200, and our assumption, our claim is that population proportion is equal to the 0.75, which is each argument. And then because we are dealing with a two-sided test, we have to set the alternative as two-sided and the correct option as false. I'm not sure about this correct argument, but let's set it as a false value. And then after running the code, you can see the result. So we can see that the p-value is 0.0032, which is the same as this value that we already got. And then it kindly gives us even the explanation that true p is not equal to 0.75. So it is the same as the result of our own testing, because we already rejected the null hypothesis, and then we already concluded that the p is not equal to 0.75 because the p-value is less than or equal to 0.05, which is confidence, I mean the significance level. So this is the end of the class, and I will summarize this class in Korean and end of this class. Thank you. 안녕하세요. 그래서 가설 검정에 대해서 나눠봤는데요. 사실은 짧게 끝내겠습니다. 사실은 가설 검정이라고 하고 저희는 이미 알고 있죠. 어떤 상황이냐면 이 표가 결국 단데 문제에서 분류를 잘 하셔야 돼요. 그래서 문제에서 저희 파퓰레이션이 모르는데 정규분포인 건 알아요. 그럼 또 갈리죠. 시그마 제곱을 줬는지 안 줬는지 파퓰레이션 베리언스를 줬으면 테스트 스태티스틱 포뮬러를 써서 세우면 그게 스탠다드 노멀 디스트리뷰션 따르는 거고 모르면 세우면 그게 t 디스트리뷰션 따르는 겁니다. 그거에 대한 테스트 스태티스틱이나 아니면 p 밸류는 앞 시간에 했던 것들을 다시 쓰는 것 뿐입니다. 그렇기 때문에 이해가 안 가신다면 사실 앞에 강의에서부터 다시 듣고 오는 게 맞긴 해요. 뭔가 방향이라던가 그런 게 헷갈리긴 하지만 천천히 생각해보면 뭐 쉽긴 하거든요. 그렇기 때문에 그것만 잘 따져보시면 되고 결국 상황만 잘 분류하면 확률만 구하면 끝이다. 그리고 그게 0.05보다 작으면 그냥 리젝하면 된다. 누를 하이퍼서시스를. 아니면 저희 파퓰레이션이 정규분포에서 왔는지 모를 수도 있잖아요. 그래도 n 샘플 사이즈가 충분히 크면 그게 또 오히려 노멀 디스트리뷰션에 따른다. 그러니까 또 써도 된다. 이 말씀입니다. 그리고 또 중요한 게 어떨 때는 투 사이드 테스트고 어떨 때는 원 사이드 테스트잖아요. 그래서 문제를 잘 보시면 어떨 때는 그냥 이즈라고 해요. 그러니까 이게 클레임을 하는 건데 어떻게 주장하는 건데 우리 에버리지가 4.5다. 그러면 이거의 얼터너티브 하이포테시스는 4.5가 아니다겠죠? 그러면 not equal 사인이 들어가는 거고 나중에 p-밸류를 구할 때도 양쪽의 확률을 구해야 되니까 투-사이드 테스트가 되는 거죠. 근데 어쩔 때는 2단데 오버리라는 거예요. 그러니까 우리의 에버리지는 160보다는 크다 라고 주장하는 겁니다. 누군가가. 그걸 증명하기 위해서 먼저 누럴 하이퍼서시스를 160으로 놓고 그거를 이제 리젝을 해서 뮤가 160보다 크다고 되게끔 설정을 하는 거예요. 애초에 처음에 이 가설 같은 거 설정할 때. 그래서 나중에 p-밸류를 구할 때도 이 한쪽 사이드만 구하는 겁니다. 왜냐하면 오버이기 때문에. 뭐 딴 것도 예를 들면 여기서 is 나왔죠? 그러니까 equal이고 not equal이고 그러니까 two-sided고 그러니까 양쪽의 probability 구해야 되고 그래서 2 곱해야 되고 이런 차이점들만 잘 알면 그리고 마무리로 proportion까지 좀 다른 경우죠. population mean을 했던 거고 앞에서는 여기서부터는 population proportion 그래서 테스트 스태티스틱 구하고 이게 스탠다드 노멀 디스트리뷰션 따르는 걸 아니까 또 p-밸류 구하고 0.05보다 작으면 리젝하고 크면 리젝 안 하고 그런 걸 반복하는 것들이고 마지막으로 덧붙인 거는 이런 함수도 있긴 한데 이게 결국 저희가 직접 구한 거랑 똑같다. 근데 사실 이 함수 쓰는 게 더 헷갈릴 수도 있거든요. 그렇기 때문에 그냥 연습을 해서 차라리 이렇게 직접 구하는 게 더 편할 겁니다. 일관적으로 문제를 잘 풀기 위해서는. 그러면 수고하셨고 다음 시간에 뵙겠습니다.